Hello, students. This is Mr. Ezra. We are starting a new unit today on something called a logarithm, and maybe you've used logarithms in previous classes, maybe you haven't, maybe a brand new thing, may not. We're going to specifically today talk about how to convert exponents to logarithms and logarithms to exponents and begin to look at how to solve some equations that have logarithms in them. So what is a logarithm? Really, a logarithm is just another way to write an exponent. In fact, is the inverse of an exponential function, is a logarithmic function. When we see logarithms, we would say that x is equal to log base a of y. Or if I had it written another way, if I had, let's say, log base 2 of 8 equals 3. Log base 2 of 8 equals 3. So this is how you say a logarithm. And let's talk about what a logarithm is. A logarithm is really the same thing as an exponent, just written differently. And we can convert very easily back and forth. Remember that we said that this is called log base y. So this part here is called the base of the logarithm. And I want you to notice that the base of the logarithm is exactly the same as the base of the exponent. So when we're converting, the base of both of them is the same. So if I want to go from logarithm to exponent, I would say base y of x equals z. The base of your logarithm raised to the power on the other side of the equal sign equals what's inside the logarithm. So what's inside the logarithm is the answer to the exponent. To go in the other direction, if I want to go from an exponent to a logarithm, I would say log base y of z is x, or x is log base y of z, right? But I want you to understand that the base of the log and the base of the exponent are the same. We kind of swoop around our, our equation to convert it. Let's look at some examples really quickly. And I think that once you practice this, it'll be very easy for you. So if you get to the point where you've seen one or two and you want to try them, pause the video, give it a try, see how you do. So we're going from log to exponent here. The base of my logarithm is the base of my exponent. So 3 raised to the other side of the equal sign. So 3 raised to the y power is equal to the inside of the log. It's equal to 5. Very simple, right? Our next example, we have a raised to the negative 2 is equal to 7. Once you get used to this, you can do it all day long. It's always the same pattern. B raised to the a equals d. B to the a equals d. Bad. So that's what a logarithm is. Kind of nice, isn't it? Pretty easy. I think so. Now, if we want to go from exponent to logarithm, we can write it two different ways. I'll show you both ways, and I'm okay with either way. I can start with the base of the exponent and say, well, that's going to be the base of my logarithm. So I'll say log, you write the word log, put a little base 10 down here, of the other side, that of goes inside the logarithm, equals the exponent. Alternatively, you can start at the exponent and say that the exponent equals log base 10 of 1,000. Either way is fine. I'm going to do it this way, but if it helps you to write it the other way, it doesn't matter. It really doesn't matter at all. Also, I'll take this moment in time to mention something to you that you'll notice that sometimes a logarithm does not have a base. So it's all about that base. If a logarithm does not have a base, it's understood to be 10. So the fact that this is a base 10 means that I don't actually have to write the base of the logarithm in there. I can write it, that's okay, but it's also okay to leave that base out and just write it as log of 1,000. It's understood to be a base 10 if there is no base there. For now, since we're just learning about these, I'm going to leave that base in there. But for the future reference, just kind of tuck that away in the back of your mind. All right, we're going to convert this next one. I like to start and say log base of my exponent is the base of my log base 2 of 8 equals x. Of 8 equals the exponent. So the answer to the logarithm is the exponent when you're converting them. You're probably getting pretty good at this. The swoop method works pretty good. So log base y of 4 equals -1. Let's also really quickly pause and make sure that we talk about the way that this looks. I want you to notice that these little guys are small and low, small and low, small and low. This is called a subscript. You don't want to write, like, you wouldn't want to write it as log base 10, 1,000 equals 3. It gets kind of confusing as to what this is. That is a bad way to write it. You want to make sure that when you write your logarithm that you use that subscript, that you write that 10 just a little lower and a little bit smaller than everything else so that it looks correct. It doesn't blend in. If you put the 2 too high here, it looks like 28 rather than log base 2 of 8. We don't want that. Another thing that you can do to make sure that your logarithm looks good, that your base is separate from inside, is you can add parentheses around the part that's inside. And this lets the person know that this is what's inside your logarithm and the other part is the base. This isn't 100% necessary unless you have a lot of stuff inside your logarithm. If it's just a number, you don't have to put parentheses, but it certainly is fine. Doesn't hurt anything. No problem with doing that. Okay, so now that we've kind of talked about how to convert from log to exponent or exponent to log, we can solve some simple logarithmic expressions, not all of them, but some of them, maybe without a calculator. I mean, we'll talk about how to use the calculator to solve them, but maybe we can do it without the calculator. This one says, what is the exponent that gives you 32? That's really what this logarithm is asking you. It's saying 2 to what power gives you 32? You can write it as an exponent. 2 to what power gives you 32? And that might be something that you can do powers of 2 in your head without a calculator and say, well, 2 times 2 is 4, and 4 times 2 is 8, and 8 times 2 is 16, and 16 times 2 is 32. So that means that x has to be 5 because 2 to the 5th power is 32. Maybe you can do that in your head. It says, what is the exponent? I'm sorry, here's our logarithm. Log base 3 of 27 equals x. And what this logarithm is kind of asking is 3 to what power is equal to 27? What's the exponent of 3 that would give you a 27? And again, this might be something that you can do in your head. You'll be like, oh, well, 3 times 3 is 9, and 9 times 3 is 27. So that must be 3 to the 3rd power. X must be 3. Let's see if you can figure out number 3. It's one that you can do in your head, but there is a little trick to it. Okay, so we got base of 4 raised to the x power is equal to 2. 4 raised to what power equals 2? Now, how can we go from 4 to 2 using an exponent? You'll have to dig back into your brain and remember that we can take the square root of a number by using a fraction exponent. So the square root of 4 is 2. So if I raise 4 to the 1/2 power, that's the same thing as taking the square root of 4. 4 to the 1/2 power is the square root of 4, which is 2. So you might be able to do that in your head if you remember that little trick. And then finally, we've got 3 raised to some power equals 1. 3 to what power equals 1? Now, This one is a little confusing at first because you're like, well, what can I multiply? 3 times 3 times 3? It's going to be too big. But anytime you get an exponent equal to 1, the exponent is always going to be the same thing. The only exponent that you can use in most of these, most cases where you get a 1 is an exponent of 0. 3 to the 0 power equals 1. So we're able to do all of these in our head without a calculator, and we're good to go. Now, I will show you in class at some point or in another video how to solve these with a graphing calculator or a regular calculator using either the change of base formula or using your calculator to actually, there's a log base command in some of your calculators that you can put it in exactly the way that it's written, it'll give you the answer. But at this point, when you get to these problems and it says to try it without a calculator, I want you to try to do it without a calculator. Try to use your rules of powers to see if you can solve these questions. So one more today for you to try. Try this one, see if you can get it. Pause the video, restart it in a second, and then check your answer. All right, so this is going to be 6 raised to some power equals 1 over 36. And there's a trick to this one. Did you remember that trick? How in the world do we get a fraction when we're starting with 6? Well, remember, to get fractions like this, we need to use negative exponents. So 6 to the negative 1 is 1 over 6. 6 to the negative 2 is 1 over 36 because that moves the 6 squared to the denominator, and 6 squared is 36. Well, that is all of the examples for today. Hopefully, going back and forth from log to exponent, it's going to be really simple for you. I think that you're going to do well with it and you're going to like it. And then solving these simple ones will be pretty easy too, I hope. If you have any questions while you're practicing, see me in class. Have a great day.